All right, welcome back to our Unit 8 notes on aquatic and terrestrial pollution. This is our 11th video all about sewage treatment. And this hopefully is a good review because we have already gone to the wastewater treatment facility, so none of this should be super new. Now, there's two ways that we look at treating wastewater. The first being a septic system. Some of you actually might have a septic system at home, where you essentially put your waste into a septic tank and then the leach field exists outside to allow for that water to be absorbed and purified. The goal here, of course, is to prevent it from getting into the groundwater. A septic tank works pretty simply. There's an inlet pipe from your home, clear water in the middle, the sludge is on the bottom. This is the the organic material on the bottom. There's a liquid level right here. Scum sits at the top, and then that clear water can be outletted into the leaching area. Obviously, you have to have ventilation here so that you can allow for oxygen to flow in and out. But this is the basic way that a septic tank works. If you want to watch a video on it, there's a 2-minute video where, if we have time, we'll watch it in class. But just you can go to that link there. You just pause this and you can go to that link, or go to the PowerPoint in Teams and you can click on that link. The other way that we can treat sewage is with a sewage treatment plant, which is just a centralized system in a large municipality in developed countries. This one's huge. The first spot in sewage treatment is primary. This is where you physically remove large objects with screens and grates, and you have waste settle to the bottom of a tank. So this is what those settling tanks look like. If you guys remember when we went in to the wastewater facility, this is what it does. The raw sewage comes in to the top, and basically it rotates the water. The solid sewage sludge comes down to the bottom, and then the sewage that does not settle, the suspended solids, will go to the secondary sewage treatment stage. Secondary treatment is more biological, where you aerate the water, you add oxygen to promote aerobic bacteria. The bacteria will break down the waste into carbon dioxide and inorganic sludge. So primary treatment is where you have screens and grit chambers to get rid of grits, and a primary clarifier where you literally just let things settle. They then send the primary effluent into an aeration tank. So you guys remember we saw this before aeration. They had anaerobic bacteria. Then they allow for the aeration to occur, and that allows for carbon dioxide to be released as those bacteria, the bugs as they call them, eat the waste away. Now obviously they have to add air. This is a huge source of energy for a waste treatment plant. Lots of energy to put the air in there. And from there, they send to the secondary clarifier, where essentially the bacteria eat the waste, the bacteria become bigger and bigger, and then when they put them into the secondary clarifier, those giant bacteria, those giant bugs will actually settle. That creates what's called activated sludge. Some of that is returned back in because it has that bacteria that they want to keep this process going, and some of that then goes to sludge treatment and disposal, depending on where you're at. This is where some places add a disinfectant and then discharge, or we go to tertiary treatment. In Reno, we have tertiary treatment. So just look into that. You should be able to label a lot of this, so I would highly recommend in your notes that you draw a rough sketch of primary and secondary treatment. Tertiary treatment, just as a reminder, typically you add chemicals. You use gravity filters to pump through and remove other products. Tertiary treatment can involve disinfection with chlorine and ozone. For us in Reno, in our tertiary treatment, they use nitrification and then denitrification to remove more of the nitrogen from the water, because they have a limited amount of nitrogen they're allowed to send back out into the water. So from a reservoir to home, this is what it kind of looks like. This is like clean water treatment, right? Not wastewater treatment. Raw water goes into screening. The screening prevents large organic matter from getting in. They then add coagulants like alum and iron chloride, which then creates a sedimentation. So those big sediments will fall to the bottom. They can have in the settling. And then it goes through a filter with carbon, sand, and gravel. They add calcium carbonate to correct the pH. They add anti-corrosive agents to help prevent the corrosion of the pipes in the process. And then they chlorinate the water to kill any bacteria, and eventually it makes it to your home. When I was in engineering school getting my engineering degree, I always remember when we took a wastewater and clean water treatment class, my teacher said, I like a little bit of chlorine in my water. When I can taste the chlorine, I know that I'm not tasting any bacteria. So that is a good point. And if the chlorine bothers you, you can literally fill up a pitcher with water and let it sit in the fridge, and the chlorine will eventually evaporate out completely. Now, there was, this is a case study from Seattle. This was in 2017, where a Seattle treatment plant was dumping millions of gallons of wastewater into their sound, into the Puget Sound. Essentially, when there are heavy rains and floods, there are certain plants that are allowed to dump raw sewage into bodies of water because they will have too much water to treat. So they are allowed to do that. And so this is an example of an equipment shutdown that, coupled with high tides and heavy rainfall, caused the Seattle treatment plant to dump millions of gallons of untreated water. And this can be a problem, obviously. So that is going to be the end of our 11th video on wastewater sewage treatment. Our next video will be all about hazards and risks.